For nearly all of human existence, we have shared our world with an enigma. Every night it rises above us, and every night we see only half of what it truly is. The other half, that vast, mysterious expanse, has remained hidden from our eyes since the beginning of time. But what if I told you that everything we thought we understood about our closest celestial neighbor is about to change? What if the secrets buried on that hidden side hold answers that could reshape how we explore space itself? Welcome to Infinite Findings, where we uncover the stories that reshape our understanding of the universe. Today we're diving deep into one of the most extraordinary discoveries in modern space exploration, a revelation that challenges everything we assumed about the moon's true nature. For billions of years, our moon has kept one face turned toward us like a cosmic performance directed exclusively for Earth's inhabitants. This isn't random. It's the result of something called tidal locking, a gravitational phenomenon so precise that it keeps the same lunar surface eternally gazing down at us. The moon completes its orbit around Earth in exactly 27 days, and in those same 27 days, it spins once on its own axis. This perfect synchronization means one hemisphere, the near side, has stared at us throughout human history, while the opposite face remains forever beyond our reach. We call that hidden realm the far side, though you've probably heard it called something else. Many still refer to it as the dark side, a name that has persisted through centuries of misunderstanding. But here's where most people are wrong. That distant terrain isn't dark at all. It receives just as much sunlight as the face we know. The darkness is only metaphorical, a darkness of mystery, not of shadow. And what lies in that mystery is far stranger than anyone predicted. For the longest stretch of our existence, humanity could only speculate. Astronomers gazed through telescopes at the familiar patterns of the near side, the vast dark regions they called seas or maria in Latin, convinced they were actually looking at oceans. They watched the countless craters pocking its surface, and they wondered endlessly about what occupied that invisible hemisphere. Some imagined civilizations in hiding. Others dreamed of alien structures waiting undiscovered. The truth would prove infinitely more fascinating than any of these fantasies. But getting to that truth required breaking through a barrier that had protected the moon's secrets since Earth was born. The year 1959 marked a turning point. Two superpowers were locked in an escalating competition, each desperate to claim supremacy beyond Earth's atmosphere. The Soviet Union had already achieved the unthinkable. They'd launched the first satellite into orbit just 2 years earlier. They'd sent an unmanned probe crashing into the lunar surface. Now they set their sights on something audacious, actually seeing the far side with a camera. They dispatched a small spacecraft called Luna 3 on a journey that would change everything. No one had ever attempted what came next. Luna 3 would swing around the moon, aim its instruments at that forbidden hemisphere, and transmit images back across the void of space. When those first photographs arrived, they were grainy and crude, barely more than blurred shadows cast through murky glass. But even through that distortion, one thing became instantly apparent. Something was profoundly different about this distant realm. Scientists had expected a mirror image. The near side features those dark, flat expanses created when ancient volcanic upheaval flooded low-lying regions with molten rock. Lava surged from the moon's interior eons ago, settled into depression and basins, cooled into solid, darkened plains. These distinctive patches make our moon instantly recognizable from Earth. But Luna 3's primitive images revealed something shocking. Those dark patches were almost entirely absent from the far side. Instead, it appeared as a completely different world, bright, cratered, mountainous, utterly unlike what faced us. How was this possible? How could two sides of the same celestial body be so dramatically distinct? The puzzle consumed scientists for decades. Their first hypothesis seemed logical enough. Perhaps the far side had endured a heavier bombardment of asteroids and comets across millions of years, a cosmic assault that shattered its surface and prevented those dark volcanic plains from ever forming. But when researchers trained their instruments more carefully on the lunar terrain, this explanation crumbled. The crater distribution didn't match what would be necessary to destroy that many volcanic seas. Something deeper was happening, something hidden beneath the surface. A new theory emerged, one that shifted attention underground. What if the moon's crust itself was fundamentally different on either side? What if the far side had developed a significantly thicker outer shell during its formation? A thicker crust would mean less opportunity for the moon's interior heat to break through and spread across the surface. Fewer volcanic eruptions would mean fewer of those dark plains. This explanation gained traction throughout the scientific community, yet it remained frustratingly difficult to prove. You cannot simply drill into the moon to measure its interior architecture. That's when NASA had a brilliant idea. In 2011, they launched an ambitious mission called GRAIL, the Gravity Recovery and Interior Laboratory. Instead of trying to physically penetrate the moon, they would use gravity itself as their measuring instrument. NASA sent 2 identical spacecraft, each roughly the size of a washing machine, into lunar orbit. These twin probes flew in perfect formation, maintaining roughly 200 kilometers between them as they traveled around the moon. As they orbited, they performed a delicate dance with the lunar gravitational field. Here's where the ingenuity becomes clear. When one spacecraft flew over regions with different densities, areas where the crust was thicker, or the rocks held more mass, the moon's gravity would pull slightly harder, altering its speed and adjusting the distance between the 2 probes. By measuring these infinitesimal variations, scientists could map the moon's interior composition without ever leaving orbit. It was like taking an X-ray image using gravity instead of radiation, revealing what lay hidden beneath the surface. The data transformed everything. GRAIL confirmed that the far side does indeed possess a thicker crust, but the findings went far deeper than that. The measurements unveiled something even more peculiar. Buried beneath the far side's ancient South Pole Aitken Basin, a depression so enormous it could swallow several smaller countries, there existed an unexpected mass of concentrated material. This wasn't just slightly denser than surrounding rock. This subterranean anomaly was so massive and so concentrated that GRAIL's instruments registered it immediately. Scientists realized they were looking at an enormous reservoir of metallic material, perhaps 5 times heavier than the entire Hawaiian island chain, compressed into a relatively confined area. How did such a concentration form? Where did it come from? The leading theory pointed towards something catastrophic occurring in the moon's distant past. Early in the solar system's history, before the planets had fully settled into their current orbits, the neighborhood of space was far more dangerous. Asteroids the size of small planets careened through the void in a cosmic game of celestial billiards. The moon, smaller and more vulnerable than Earth, bore the brunt of this onslaught. At some point, a truly colossal impactor, a space rock perhaps as large as a mountain, smashed into the far side with unimaginable force. The collision was so violent that it didn't just create a crater. It punched through the moon's crust, exposing material from deep within. The tremendous heat and pressure of impact may have altered the composition of rock at that location, perhaps even inducing unusual chemical transformations in the underlying layers. The evidence for this catastrophic impact still marks the far side like a scar, but NASA and international space agencies wanted to learn more, so they sent robotic explorers to visit these remote sites. China's U-22 rover, no larger than a small outdoor appliance, traveled across the far side's desolate terrain, conducting experiments on material that no human had ever examined. The rocks it encountered differed noticeably from samples astronauts had collected during the Apollo era. These ancient stones whispered different stories about how the lunar interior had cooled and crystallized billions of years in the past. And then U-22 discovered something that sparked both scientific intrigue and online confusion. The rover's cameras spotted an unusual material protruding from the soil, something the research team described with an unexpected word. They called it gel-like. The description immediately ignited imaginations online. Had they discovered something organic? Some kind of biological substance in a world known for its absolute sterility? The reality, while no less remarkable, proved more straightforward. What U-22 had encountered was impact glass silicate material that had been heated to such extreme temperatures during a violent collision that it had melted completely, flowed like liquid, and then crystallized into a smooth, glassy substance as it cooled. Not alien biology, but a natural testament to the violent forces that have sculpted this world. The story now takes an unexpected turn, shifting from ancient history to an unfolding present. The far side is no longer merely an object of distant study. It is transforming into a destination. Space agencies worldwide are designing missions to land there, to conduct research on its surface, to extract its resources, and eventually to establish permanent human presence. This transition from mystery to destination represents one of the most significant developments in space exploration. NASA's current lunar program is named Artemis, honoring the moon goddess in Greek mythology. Unlike the Apollo missions of 50 years ago, brief visits where astronauts planted flags, collected rocks, and departed, Artemis envisions something unprecedented. NASA wants to build infrastructure that would support sustained human habitation. We're talking about habitats, laboratories, mining equipment, and regular transportation routes between Earth and the lunar surface, and the far side features prominently in these plans. Scientists have proposed constructing an orbital platform called Gateway that would hover above the moon like a cosmic hub, a staging point for expeditions to both hemispheres. But some researchers have advocated even more ambitiously, suggesting that the far side deserves missions dedicated exclusively to its exploration, particularly around the South Pole region where ice may lie hidden in permanently shadowed craters. Access to that frozen water would provide resources for sustaining human outposts and fueling spacecraft bound for deeper space. The implications extend far beyond scientific curiosity. Nations currently developing independent lunar capabilities include not only the United States, but also China and Russia. Multiple space agencies are engineering specialized landers and instruments designed specifically for far-side deployment within the coming years. This represents a genuine shift in how we think about space, from a place we visit to a place we build within. The geopolitical dimensions of this movement deserve serious consideration. International treaties from the 1960s declared that no single nation could claim ownership of the moon or other celestial bodies. But those agreements were drafted in an era when lunar habitation seemed impossibly distant, a dream for the indefinite future. Today's reality is different. The first nation to establish functional infrastructure gains significant influence over how the moon will eventually be governed and utilized. China has unveiled ambitious plans to construct a research station on the lunar surface, with Russia as a collaborative partner in this venture. The United States, through Artemis, has assembled a coalition of allied nations committed to principles of peaceful cooperation, formalized through the Artemis Accords. What makes this competition particularly intriguing is how quietly it unfolds. While these plans take shape in laboratories and conference rooms, most of the world remains largely unaware. Countries are mapping unprecedented detail, launching instruments designed to answer specific questions, and preparing hardware for launch. Multiple spacecraft currently en route to the far side belong to different nations pursuing different objectives. Some focus on scientific investigation, others aim to test technologies that might eventually support human exploration. All of them represent steps toward transformation of that mysterious hemisphere into a known, inhabited, economically significant domain. This context helps explain why the far side has become one of the most contested and coveted regions in our solar system. The buried metal concentrations offer potential economic value. The water ice presents logistical opportunities. The radio silence and absence of Earth-based electromagnetic interference makes the far side uniquely suited for astronomical observations of profound importance. Telescopes positioned there could observe the universe's earliest light, providing windows into cosmic history that Earth-based instruments cannot achieve. These factors combine to make the far side scientifically precious and strategically valuable. Consider the bigger picture and what it means for our species. The moon has orbited Earth since our planet solidified. Long before humans appeared, its gravitational pull shaped our world's oceans, creating the tidal patterns that have governed life's existence on land and sea. The moon's presence stabilizes Earth's axial tilt, maintaining the climate equilibrium that allows sophisticated life forms to flourish. Without it, our world might wobble chaotically through seasons of destructive extremity. The moon isn't merely a pretty night sky ornament, it's a fundamental component of the system that makes our existence possible. Yet for all the centuries we've studied it, we only ever perceived half of it. The far side remained hidden, and what occupied that hidden realm turned out to be stranger and more consequential than anyone imagined. A crust thicker and more complex than the accessible hemisphere, a massive buried concentration of unusual material locked beneath ancient impact scars. A terrain so cold that temperatures plunge far below anything most of us could fathom, colder even than frozen distant worlds orbiting the sun. trapped water molecules that could sustain future generations of explorers, a profound quietness so complete that it could allow us to listen for the universe's primordial radio whispers from the epoch of cosmic creation itself. Each of these discoveries emerged from asking a deceptively simple question: what exists on the opposite side? That straightforward query launched Luna 3 across the lunar orbit in 1959. It motivated the creation of gravity mapping instruments that revealed the moon's hidden interior. It sent mechanical explorers crawling across alien soil, analyzing rocks that human hands have never touched. Now that same question is driving humanity toward an even bolder future, one where we don't just observe the far side, but inhabit it, build upon it, and perhaps even transform it according to our needs. The far side is no longer the endpoint of a mystery, but the beginning of an entirely new chapter in human exploration. We stand at the threshold of an era where that distant hemisphere transitions from unknowable enigma to accessible frontier. What NASA and other international agencies have discovered, there is not a conclusion, but a gateway, an opening toward possibilities that would have seemed like fantasy a mere few decades ago. The discoveries keep multiplying, the missions keep launching, and our understanding deepens with each passing year. If this has transformed how you perceive that constant presence in our night sky, then these final thoughts are for you. Subscribe to Infinite Findings so you're here when the next extraordinary findings emerge, and they will emerge faster than most realize. Enable notifications so you never miss the moment when a landing happens, when a breakthrough is announced, when history unfolds in real time. And in the comments, share your thoughts with us. If you could ask the far side of the moon one question and receive a real answer, what would you want to know? What mystery still calls to you? Finally, share this with someone you know who's dismissed the moon as something we've already mastered, someone who believes we've learned all there is to learn. The reality is, we're only beginning to scratch the surface of what that hidden world contains. Thank you for exploring these cosmic mysteries with Infinite Findings. Until next time, keep questioning what lies beyond our horizon.